In the previous videos, we talked about producing rock sections as a part of the work in the engineering plan. It gives information regarding the conditions of the road and its surrounding areas. Among the important informations include the proposed road level, the components of the roads, the dimensions, the lot boundary, the elevations of the adjacent areas, the gradient of the road, as well as the slope. We also mentioned that the construction work can only be done within the lot boundary. No construction work shall be allowed on the adjacent land unless you get the consent from the respective landowners. By all means, you should not disturb the existing conditions of the adjacent lot. You will need to prove that you have successfully acquired the consent of the adjacent landowner if the construction works involve the adjacent lot. Otherwise, during submissions to the Land and Survey Department, your submissions will not be able to get through. As you can see from the example road section here, the existing earth level is relatively low as compared to the proposed road level. There will be a significant difference in terms of the elevations. This design deals with the slope with a gradient of 1 to 2 in the adjacent lot. This definitely will have to get the consent from the respective landowners. Let's say now you are unable to get the consent by the landowner. Now this slope design cannot be applied. For that, you will have to work out a retaining wall without trespassing into the adjacent lot and impose no changes to the existing conditions of the adjacent lot. Now, when there is differences in terms of the elevations, as a safety precautions, the safety rail shall be required. As you are providing the retaining wall as well as the safety rail, you will need to provide detailings for both components. This is an example of the detailings for the retaining wall. You will need to clearly indicate the reinforcement for the retaining wall, as well as the dimensions of the retaining walls. This shows the typical details for the safety rail as a barrier to the traffic, as well as to prevent public from falling at height. Give the dimensions, materials and sizes, as well as the specifications. Next, let us look at general requirements of road sections by the local authorities. Different places may have different requirements depending on the local authorities. Here are some general requirements for the road sections. Some local authorities clearly specify the required pavement thickness. For example, the subgrade needs to be well compacted. 6 mm quarry sand in between the subgrade and the subbase course, 230 mm subbase, 75 mm for the base course, and at least 80 mm for the premix finish. For example, the road pavement details as shown here. The subgrade is the lowest layer of the pavement, which it should be well compacted, and then a quarry sand layer of at least 6 mm thick, followed by 230 mm subbase course of 75 mm down crusher runs, and then base course 75 mm of 35 mm down crusher run, and then the binder course and wearing course. The two layers here are premix finishes, which needs to be at least 80 mm thickness, which in this case in total is 100 mm. For the other requirements, the corner radius needs to be at least 6 meters in order to avoid sharp turning. 200 mm size pipe spaced at 3 meters center to center as the width hole, collecting the surface runoff from the road surface and direct them into the concrete drain. This is to prevent the ponding of water at the edge of the road while raining. There are also requirements in terms of the gradient. The gradient of the carriageway should fall in the range of 1:40 to 1:32. 1:40 gradients is milder. 1:32 it will be stiffer. The gradient will influence the flow of water on the surface of the road. Let's say now in this case we use the fall of 1:32 to quickly discharge the surface runoff from the road surface in order to prevent slippery roads during raining period. There are also requirements in terms of the gradient for the grass verge, where the gradient needs to be milder than 1:24. You may use 1:24. In this case, we just stick to the same gradient as per the road surface. For the footpath, the gradient needs to be milder than 1:40. Now, if the footpath is at the same levels of the road surface, you may have the gradients heading towards the drain. If the footpath is slightly higher than the road surface, you will require pipes as the width hole, directing the waters into the drain. These are the typical requirements for the footpath. Minimum 100 mm thick, 1 layer of fabric mesh, and it should be sitting on top of well compacted hard core. There are also requirements in terms of the slope gradient. Now, if the elevations exceed 3 meters, the horizontal to vertical gradient shall be of maximum 2:1, which is milder as compared to the height less than 3 meters of gradients 1:1. Now, the backfill soil to form the gradients needs to be well compacted and properly turfed. The species of the turfing are specified. In the case that you will require stiffer slope, then the slope needs to be properly designed. The calculation steps needs to be demonstrated and submitted to the local authorities for approval. The other requirements for the road sections include the velocity of overland water flow, that not to exceed 0.5 meters square per second, in order to ensure the stability of the vehicles and the safety of the pedestrian. This requirement can be obtained from MASMA 2. These are the examples of the requirement checklist given by the local authorities. You may check your design against the checklist, as the local authorities shall do the same during the submissions. They will need to make sure that you fulfill the requirements by the checklist. Only then approval shall be granted. Sometimes there will be comments. You will need to make sure that comments are also fulfilled in the subsequent submissions.